can watch the video since I am recording it if you decide not to take the notes now. Um, yeah. All right. So, use substitution. So, the big idea here is that this is the inverse of the chain rule. So, I don't know if I made that super clear. Um, okay. So, this is like the opposite of it. So, um, when you differentiate a composite function, you use the chain rule. Well, when you're integrating a composite function, you use U substitution. So, you use this when you have a composition. So, what that means is like an inside and outside function. So, um, you look, things to look for. A function inside of a function. A function inside another function. Oh, I did. Sorry. I don't think it's being shared. That would be a problem. Where is. Sorry about that. I'm going to share it now because I am writing. Okay. So, a function inside another function. And so, what that looks like is say I have something like x squared plus 1 to the fifth. This is inside of parentheses. If I was to identify an inside function, it would be x squared plus 1. And the outside function would be like x to the fifth. Or the unknown to the fifth. So we look for a function inside of another function, but there also has to be the derivative of the inside function within it. The derivative of the inside nearby. Or at least part of it. So, for instance, with this, x squared plus 1, to be able to use U substitution, you would need like 2x with it because you would need to have the derivative with it. Now, if you don't have 2x, you at least have to have the x part. But if we look at this example, what we do is we identify the u. So in this case, fabulous. So in this, u is the inside function. So then I have to say, well, what's the derivative of u? That would be, and then you put the dx because that was taking the derivative with respect to x. So now, if I look at what I did here, I said this now, if I rewrite this, this is the u. So I would say u to the fifth, and then the rest of my problem, 2x dx, is du. So at this point, all I did was rewrite it using my u. Okay? So now we take the antiderivative here, which is what you, okay, correct. Because this is u to the fifth. Because u was x squared plus 1 to the fifth. So the u to the fifth comes from right here. Correct. So at this point now, you can integrate. Take the antiderivative. So when we do that, you increase your exponent, divide by the new exponent, and always put your plus c. And then from this, we want to substitute for u because we want to get this back in terms of x. So this is going to be the u was x squared plus 1 to the sixth divided by 6. Right. Yeah, all I did was now were there, yeah, substituted for u. All right. So we're going to just do a few examples like together um, because I just think going step by step like this, and I'm going to go slower because I know um, the goal is I want to make sure you understand what we're doing. Yep, that's it. Yeah, yeah. All right. So now, say we have 2x over x squared plus 4 dx. So now, the first thing we want to do is choose our u. That's exactly what it is. So x squared plus 4 is our u. So we already kind of know when I rewrite this, I'm going to have a u down here, right? All right. So now, what is the derivative of u? 2x dx, yep. Now, the 2x dx is right here. So that is my du. And I can't leave this empty, so I just put a 1 there. Because the 2x and the dx went away because 2x dx is du. All right. So the 2x and the dx is du, correct? 2x dx, that is du. So I had nothing on top of this. You can't just leave it like empty. So I put a 1. Right. It's put up. All right. So from here, now we take the antiderivative.
Mama, I fell behind my bed.
What fell behind your bed?
I don't know.
All right. I'll find it in a few minutes, okay? Sorry. So we integrate. Now, the antiderivative of 1 over u, we talked about, like, well, that was one of them that we had to write. We wrote down. Well, so yeah, that's true. That's the same as u to the negative 1 du. But if I try to decrease this, that's going to become 0 divided by 0, and you can't do that. So if I don't, you might not remember, but we said that means that this is natural log. The antiderivative of 1 over u is natural log. And that's just a property you kind of have to remember. But hopefully, like when you go to take the antiderivative and you see you're going to divide by 0, you will remember, like, I can't divide by 0. And so it's going to have to be something else. So now once you're here, you substitute for u. So that would be the natural log of x squared plus 4 plus c. All right. So the rule we have says that it's a rule that says when you have um, oh my gosh, okay. That's just like that's a rule. Thank you. That's a rule that we wrote in some notes the other day when we were writing some notes with trig. We wrote the natural log. We also wrote um, that e to the x, the integral there would be e to the x plus c. So like that was another rule we wrote. Mm-hmm. 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 Exactly. Yep, that's it. Once you substitute back in, you can be done. Because you could just take you didn't end up dividing by 0. You could do like you could actually take the antiderivative of u to the 5th. If you tried to take the antiderivative here, that would give you u to the 0 divided by 0. And you can't do that. Yes. So let me show you. Let's look at, say we have, um, all right. So if I have this, what would you let your u be? Yes. Well, what's the derivative of 4x? 4, right. So 4 dx. So looking here, my u is this. So that is u to the 7th. And then 4 dx is this part. And that is the same thing as du. So all I did at this point was rewrite the problem using u instead of x. You don't have to use either of those rules because you can just take the antiderivative here because the antiderivative says increase the exponent by 1 and divide by the new exponent. And have to go to a rule. Right. All right. So what do I do from here? Mhm. So at this point, that is it. You're done. Okay. So let's look at one. All right. Let's say we have the integral of 2x times the square root of x squared plus 9 dx. So at this point, what would you say your u is? Mm-hmm. So then what is the derivative of u? Fabulous. And so at this point, I have the u to the 1/2 because this is 1/2. And then the 2x dx is du. Yes, it would. Okay. Now, like when you're taking the antiderivative, you increase the exponent by 1. So that becomes u to the 3/2 because 1/2 plus 1 is 3/2. And we divide by 3/2. And so we don't want to leave this looking like this. Um, so, uh-huh. All right. Because you say 1/2 plus 1, which is 3/2. Because you always, when you take the antiderivative, you add 1 to the exponent. Okay. So that's 1/2 plus 2 over 2, because 1 is 2 over 2. Yeah. And so, do you understand how this divided by 3/2 became 2/3? So, when you divide a fraction, that is the same as multiplying by the reciprocal, which means you multiply by the flipped fraction. So when you divide by a fraction, you multiply by the flipped fraction. Yeah, so this u to the 3/2 divided by 3/2 is the same as 2/3 times u to the 3/2, which is where that came from. So what I'll do is I'll show that middle step here. I don't know why this is taking so long. It's like a delay. Oh, hello. All right. So what I mean is when you divide by 3/2, that's the same as multiplying by the flipped fraction. Oh, I meant to put this up here. My computer is acting up. And so once you've done that, you can substitute back in for our u. So at this point, I have 2/3 u, and our u was x squared plus 9 plus c. Did you follow that to the end? Okay. So now this next one, we have an e to the 5x. So what would our u be? Now, what is the derivative of 5x? 5. So now, yes. So we have e to the u, and I have part of the du here. But what am I missing? Like, here's the dx, but there's no 5 anywhere in this problem. So when that happens, you have to like take the 5 out. So that's like you're going to have to take up for that by having the reciprocal. So kind of another way to think about this is if you solve this for dx, that would be 1/5 du. So you could pull that 1/5 on the outside. Yeah. So the thing is, you see how when I'm putting this back into the problem, for to be able to put du in, I would need to have a 5 somewhere in this problem. And do you have a 5? Do I have a 5 that's not part of that 5x? Like right here, there's no just 5 coefficient being multiplied. So since there's no 5 here in this problem, you can't really just plug a du in here because there's du is 5 dx, and we only have the dx part. So to take up for the dx, the 5, what you could do is you could solve this for dx. So if you divide by 5, you would get 1/5 du. So in place of this dx, I would have a 1/5 and a du. Now, if this is confusing written this way, you could also write it like this. And so in place of the dx, I put a 1/5 du. So from there, I want to be able to take the antiderivative of EU. And we said earlier in that rule I wrote down, the antiderivative of E is E. So that's going to be e to the u plus c. And so at this point, I just replace my u with the 5x.